Solving systems by elimination. It says solve the following systems by elimination. Elimination is best used when neither equation is solved for a variable. So like with substitution, if you remember from the last lesson, we'd always have like a y equals or we'd have an x equals. That led us to use the substitution method because we could substitute that expression into the other equation. So elimination, if you notice, neither of these say x equals, we're looking at letter A, say x equals or y equals. So we can't use the substitution method initially here. But there's this really kind of interesting property with mathematics is that you can add equalities. Like for instance, don't write this. Let's say you have 8 equals 8 and you have 3 equals 3. Those are both true. If you just add them down, it's still true. And this is just kind of a property with mathematics. So what we can do is we can add equations down. And in doing so, we can sometimes eliminate variables. So here's the first case. It says where the equations are already set up to eliminate one of the variables. So if you'll notice on A, if we add these equations down, if we add them down, the y's are going to eliminate. The y's are going to eliminate, and then we'll be stuck with just one variable x, and we'll be able to solve for it. So we add them down. The y's are going to eliminate. On this side, 5x plus 2x would be 7x. And 43 plus 13 is 56. So then, so that's the whole point. We can eliminate one of the variables so that we have a single variable equation that we can solve for. So divide by 7. X is 8. Now to get y, of course, we need to plug 8 in, substitute 8 into either one of the equations to get y. So I'm going to put it in the first equation. So the first equation says 5x plus 3y equals 43. So x is 8. So I'm going to have a 5, 8. Put 8 in for x. Plus 3y equals 43. 5 times 8 is 40. Subtract 40 from both sides. Divide by 3. Y is 1. We'll write it as an ordered pair, 8, 1. And that's it. So this case 1, as we see it, where they're already set up for elimination, we can just add them down, eliminate one of the variables, and start solving. So if you'll notice on B, the x's, and I'll let you do this one. The x's are already going to eliminate. Negative 2x plus 2x's, those eliminate, be 0. Okay. Case 2, where one of the equations needs to be multiplied to be able to eliminate one of the variables. Okay. So if you notice right here, don't write anything yet. If I add these down, this becomes 4x, this becomes negative 3y. That would be, that doesn't help us. That doesn't help us. Neither of the variables eliminate. So that doesn't help us. So what we need to do is we need to manipulate one of those equations so that it does eliminate. So this is where it kind of becomes strategic. You want to figure out, okay, do I want to eliminate the x's? Do I want to eliminate the y's? And the truth is it doesn't matter. But what I'm going to do here is I'm going to try to eliminate the x's. So right now I have an x plus an x and a 3x. I need those to be opposites. So I'm going to multiply this by negative 3. Because if I do that, if I multiply this by negative 3, so I'm going to multiply this by negative 3. If I do that, then I'll have a negative 3x, and then that positive 3x will eliminate. So here we go. So I'm going to multiply that by negative 3. That's going to be negative 3x. And of course, I got to multiply the entire equation by negative 3 to maintain that equality. 2 times negative 3 is negative 6y. And then that would be negative 30. And then I'm going to rewrite the second equation underneath it. So there you have it. That is the setup. I needed to multiply that first equation by negative 3. So that now the x's will eliminate. Add down, x's eliminate, This becomes negative 11y when I add it down. That would be negative 33. Divide by negative 11. Y is 3. So again, the only difference is I just had to manipulate one of the equations so that you could eliminate. So y is 3. So now I'm going to plug in 3 for y in either equation. I'm going to plug it into the original first equation. So the original first equation was x plus 2y equals 10. So I'm going to have x plus 2. We know y now is 3. And this equals, whoops, why did I write y? Y is 3. 2 times 3 is 6. Subtract 6 from both sides. X is 4. So 4, comma 3. Remember, we have to write it in the order of x, y. Okay. So for B, I'll just kind of give you a hint. You'll probably want to multiply this equation by 2, because then you'll have a negative 2y, which will eliminate with the 2y, and then you can solve for x from there. Number 3, case 3, where both equations need to be multiplied in order to eliminate one of the variables. So right now, like as it stands, we can't multiply this first equation by this 3x by anything to get negative 2x to eliminate there. So that's not gonna work. And we can't like multiply this 4y by anything to get negative 5y to eliminate with this. So what we're gonna have to do is we're gonna have to multiply both equations. So since 3 and 2 are smaller numbers, I'm going to work with those instead of the 4 and 5. So I think, okay, what's a common multiple of 3 and 2? And that what comes to mind is 6, right? The common multiple of 3 and 2 is 6. So if I can get one of them to a positive 6 and the other one to a negative 6, then I can use elimination. So that's my goal. So I'm gonna multiply this first one. I'm going to get this first one to a negative 6. So I'm going to multiply this one by negative 2, because that's going to give me a negative 6x. And I'm going to multiply the second one by a positive 3, because that's going to give me a positive 6x. Okay, so let's see what my new equations look like. Negative 6x minus 8y equals 18 times negative 2, negative 36. 3 times 2 is 6. 3 times 5 is 15. 3 times 19, what is that, 57, I think? Yeah. And there we have it. So I manipulated both equations. I multiplied the first one by negative 2 to get me that negative 6x, multiply the second one by 3 to give me that positive 6x. Now, it's set up for elimination. You add them down. These will eliminate. Oh, I forgot the y here. Add these down. This would be, what's that, 7y? And then this would be negative 36 plus 57 be 21. Whoops. Divide by 7. Y is 3. Now I got to take 3 for y, plug it into either equation. I'll just plug it into the first one. So it's 3x plus 4y. But we know y is 3 now. So I'm going to put a 3 in for y equals 18. 4 times 3 is 12. Subtract 12 from both sides. 6. Divide by 3. Whoops. X would be 2. So solution 2, 3. So yeah, that's how it works. Let me show you one more case with a word problem. It says Paulo and Carmelo went trick-or-treating and got a bunch of fun-sized candy bars. They calculated their total sugar intake. Paulo ate 3 Butterfingers and 1 Twix for a total of 51 grams of sugar. Carmelo ate 2 Butterfingers and 4 Twix for a total of 64 grams of sugar. Write a system's equations that can be used to solve for the amount of sugar in Butterfingers and the amount of sugar in Twix. Okay, so I'm going to first write an equation for Paulo. Okay, so Paulo's 3 Butterfingers and 1 Twix. So I'm going to write 3b plus 1t equals, how much did he eat? What did it say? 51. That's Paulo. Yep. Carmelo, 2 Butterfingers. So 2B plus 4T, because he had 4 Twix, for 64 grams of sugar. So B represents the amount of sugar in a Butterfinger. T represents the amount of sugar in a Twix. So now we have our system. So now I'm going to try to solve that system. Let me just, I have plenty of space, so I'm just going to rewrite it down here. Hopefully my B's don't look like 6s. I always run into that problem. Okay, so here's my system, and we're going to try to solve this by elimination. So I have some options of how I want to do this. I could try to eliminate B, or I could try to eliminate T. So if I wanted to eliminate B, I have a 3 and a 3B and a 2B. I could get them to 6. I could get a negative 6B and a positive 6B, because common multiple of 3 and 2 is 6. Or I think it might be easier, I could eliminate the T. And I could, because that's a 4T down here, right? And I could make that top T a negative 4T by just simply multiplying this equation by negative 4. So that's what I'm going to do. So that's going to be negative 12B plus, well, let me write minus, because it's negative 4 times 1 be minus 4T. Negative 4 times 51, that'd be like negative 204. Whoops. Now I'm just going to rewrite the second equation, because I'm not manipulating that one. Okay, so now it's set up for elimination. Add down. The T's eliminate. Exactly what I wanted to happen. Negative 10B equals, you add those down. I think it's negative 140. Should be right. And then divide by negative 10. B is going to be 14. So what that means is that Butterfingers have 14 grams of sugar in them. Found that out. Now let's figure out how much Twix have in them. So I'm going to take that 14. I'm going to plug it in for B in either equation. I'm just going to plug it in the first one. 3, I'm putting 14 in for B. Plus T equals 51. 3 times 14 is 42. Subtract 42 on both sides. T is going to be 9. So Butterfingers, again, doesn't make sense to write this as an ordered pair. Butterfingers have 14 grams of sugar. Twix have 9 grams of sugar. So that's a word problem. So I'll let you do the rest.